Okay, let's integrate this, but using the hyperbolic functions. Let's take x to be equal to a cosine hyperbolic of z, and z is a new variable. Now here, cosine hyperbolic is always positive, so a is also positive and x would be positive. So here by doing this, we miss the negative values of x again, which, as before, this is an even function, and its formula and its integral, the formula of its integral is the same for the negative values of x. So let's plug it into x. And according to the formula below, this is equal to the square root of sine hyperbolic square, which is equal to the absolute value of sine hyperbolic. Now, cosine hyperbolic of z is an even function. So, in x equals to a cosine hyperbolic of z, the values of x for the negative values of z equals to the values of x for the positive values of z. So here, let's work with the positive z's, the positive values of z, and for the positive values of z, e to the z is greater than e to the minus z, because e is approximately equal to 2.7 and is greater than 1. So e to the z, to the positive z, is always greater than 1. But e to the minus z is 1 over e to the z. So it is always smaller than 1 for the positive values of z. Okay, then this is always positive, and this is the sine hyperbolic of z. So we could get rid of the absolute value, and dx would be equal to this. So substituting everything makes the integral equal to this. Now sine hyperbolic squared of z equals to cosine hyperbolic of 2z minus 1. We could easily derive that. This came from the formula below, and also the formula for cosine hyperbolic of 2z, which is cosine hyperbolic squared plus sine hyperbolic squared of z. Okay. Now this is equal to this, multiplying and dividing the first integral by 2 takes us to this. Also, the second integral equals to z plus a constant, of course. Okay, now the first integral equals to the sine hyperbolic of 2z plus another constant. Let's take the constant of this and the second integral as c1. And according to the formula for sine hyperbolic of 2z, it is equal to this. Now, from the formula top right, cosine hyperbolic of z equals to x over a. And now from this formula, sine hyperbolic squared equals to this, or sine hyperbolic of z equals to this. The as I said before, we work with the positive values of z. Okay, and z from here would be equal to the inverse function of cosine hyperbolic of x over a, which was equal to ln of this. Okay, it's done. Thank you.